Welcome back to Topic 4 for Algebra 1, Number of Solutions to Linear Equations. In this video, we're going to solve some examples and use our final answers in order to correctly label and identify the number of solutions to these linear equations. Keeping in mind what we learned in Topic 3 about solving multi-step equations with variables on both sides, we're going to refer back to those steps for guidance. So what I'm first going to do with this example, x plus 2x plus 3 plus 4 equals 5x plus 8 plus 6x plus 7, is draw a vertical line to separate the left-hand side from the right-hand side. On the left-hand side, then we're looking to distribute if possible. In this example, we don't need to distribute. Then we are going to combine like terms on each side of the equation. So this refers both to the variables and the constants. On the left-hand side, we have x and 2x, and we also have 3 and positive 4. X plus 2x, since this is really 1x plus 2x, gives us a total of 3x, and then 3 plus 4 adds to positive 7. On the right-hand side, we have 5x plus 6x, and 8 plus 7. 5x plus 6x gives us 11x, and 8 plus 7 gives us 15. Now we're going to move the variable to one side of the equation and move the constants to the other. So let's decide. Let's say we want our variable to be on the right-hand side, and then our number to ultimately be on the left-hand side. It doesn't matter which side you have the variable be in the end and which side you have the constant. Your answer will still be the same. It's just your route to get to that answer might look a little bit different, or it might have one or two more steps in it. What we're first going to do is now move the variable to one side of the equation. Since we decided that the variable will land on the right-hand side, since I have this positive 3x, remember, if we don't see an operation, it's automatically positive, or being optimistic here, I'm going to use the inverse of addition and subtract 3x from both sides. Remember, lining it up vertically with those like terms. 3x minus 3x adds to 0, and I'm going to bring down that 7. Then on the right-hand side, simplifying, we have 11x minus 3x, which gives us 8x. And then bring down our positive 15. Now, since we want to move our constants to the left-hand side, I see a positive 15 on the right-hand side, so I'm going to subtract that. And what I do on one side, I must do on the other side. On the left-hand side, we have 7 minus 15, which gives us negative 8. On the right-hand side, we'll bring down our 8x, and 15 minus 15 adds to 0. Now we have negative 8 equals 8x. Since this is really 8 times x, we're going to use the inverse of multiplication and divide both sides by 8. Now, how did I know to divide both sides by positive 8 and not the negative 8 I see? Well, remember, we want to get our variable x alone. And what is clinging on to dear life to that x? It's this positive 8. It's the coefficient right in front of it that's attached to it. So that's how we choose what number that we're going to divide by in this case. Positive 8 divided by 8 reduces to 1, or 1x. And on the left-hand side, negative 8 divided by 8 gives us negative 1. So if we want to rewrite this, this is the same thing as x equals negative 1. Now we can check our solution by plugging back in. So we have everywhere that we see an x, we're going to plug in a negative 1. So negative 1 plus 2 times negative 1 plus 3 plus 4 equals 5 times negative 1 plus 8 plus 6 times negative 1, ooh, cramming it in, plus 7. A little crammed there. Okay, now we can multiply. On the left-hand side, we have negative 1 plus 2 times negative 1, which is negative 2, plus 3 plus 4. On the right-hand side, we have 5 times negative 1, which is negative 5, plus 8, plus 6 times negative 1, which is negative 6, plus 7. Now, using PEMDAS, we can simplify. So because PEMDAS, addition and subtraction are interchangeable, you simplify whichever you see first, going from left to right. Negative 1 minus 2 is negative 3, plus 3 plus 4. Negative 3 plus 3 is 0. So we have 0 plus 4, which simplifies to just 4. On the right-hand side, negative 5 plus 8 is positive 3 minus 6 plus 7. Positive 3 minus 6 is negative 3 plus 7. Negative 3 plus 7 is 4, so our equation is balanced. Therefore, x equals negative 1 is our solution. Now, when we have one number equivalent to our variable, this is called one solution, and it's what you're probably familiar with from the problems that we solved in topic 3. Let's move on to another example. Here we have 2x minus 6 equals 2 times x minus 3. Now, I'm going to first draw my vertical line to separate the left side from the right side. Then I'm going to distribute. I don't have to distribute on the left-hand side, but I can on the right-hand side. So 2 times x and 2 times negative 3. On the left-hand side, I still have 2x minus 6, and on the right-hand side, I have 2x, and 2 times negative 3 is also minus 6. Now keep in mind what you see on the left-hand side and the right-hand side. Thinking back what we would do before, we cannot combine like terms on the left-hand side or the right-hand side, so we're now going to decide which side of the equation we want our variable to end up and which side we want our constants. Let's have our variable be on the left-hand side and our constants be on the right-hand side. And when I say constants, I just mean the number that does not have a letter or variable attached to it. So in order to move our variable to the left-hand side, I need to take this 2x that's on the right-hand side and bring it over. So in order to do that, since this is a positive 2x, I'm going to subtract 2x, do the inverse, and subtract it on the left-hand side as well, lining it up with my like terms. On the left-hand side, we have 2x minus 2x, which gives us 0. And then I'm going to bring down my negative 6. On the right-hand side, 2x minus 2x, this is what we initially did, adds to 0 as well. So we'll bring down our negative 6. Now we want to have our constants be on the right-hand side. Since this is a negative 6, on the left-hand side, we're going to add 6 to both sides. Negative 6 plus 6 cancels and adds to 0, so we're left with 0 on the left-hand side, and on the right-hand side, negative 6 plus 6 also adds to 0. So what we have here is 0 equals 0, and our variable has disappeared. For our solution then, this is called all real numbers, which is sometimes referred to this symbol, or infinitely many solutions. And this is because no matter what value you plug back in for x, keeping in mind that it's a real number, no matter what value that you plug in for x into the original equation, your variable is going to disappear in the end and you will end up with 0 equals 0. So there are infinitely many solutions for our variable x in this example. Our next example, we have negative 4x plus 3 times 5x plus 6 equals 7 times 2x plus 1 minus 3x. So what we're going to do first here is draw a vertical line through our equation, separating the left side from the right-hand side. Now we're going to distribute. Notice here we can distribute on the left-hand side and the right-hand side. On the left-hand side we have negative 4x plus 3 times 5x is 15x, and 3 times 6 is positive 18. On the right-hand side, we can distribute 7 times 2x is 14x, and 7 times 1 is positive 7, and then bring down my minus 3x. Now, before we choose a side for our variable and our constants to end up, we're going to combine our like terms. We have negative 4x and 15x on the left-hand side. This will add to positive 11x and then plus 18. On the right-hand side, we have positive 14x and negative 3x. Once we add them together, we'll get positive 11x plus 7. And notice what you see here. Now we're going to decide which side we want our variable to end up and which side we want our constant to end up. Let's have our variable be on the left-hand side and our constant be on the right-hand side. So in order to move this 11x to the left-hand side, what we need to do is, since this is a positive 11x, we're going to subtract 11x, use the inverse. On the left-hand side, we have 11x minus 11x, which is 0, and then bring down my 18. On the right-hand side, 11x minus 11x adds to 0, it cancels out, because that's what we initially moved, and then bring down my positive 7. Then what we have on the right-hand side is we want to move our constants over there. So we need to move this 18 to the other side. What we're going to do, since this is a positive 18, is subtract 18 from both sides. On the left-hand side, we have 18 minus 18 adds to 0, and we're just going to be left with this 0 on the left-hand side. On the right-hand side, we have 7 minus 18, which gives us negative 11. Now, does 0 ever equal negative 11? No, it is not equal. So this is actually called no solution. There is no possible number that we could plug in for x into the original equation so that our equation would be balanced in the end. Sometimes you might see the symbol of 0 with a slash through it, or you might see the word null, but it's commonly referred to as no solution. So that was topic 4 for Algebra 1, number of solutions to linear equations, where we learned about one solution, infinite solutions, and no solutions. Thank you for watching.